Welcome to Electricity Basics for Solar Photovoltaic Systems. This section covers the basics of electrical parameters, namely volts, amps, resistance, power and energy, how to use a multimeter, basics of series and parallel electrical circuits. Electricity behaves like water flowing down a garden hose. Water is easily understood, and electricity is just the same. The amount of water flowing in a hosepipe system is like the amount of current in an electrical system. If you have more water flowing, you have more current in an electrical system. The amount of pressure on the hosepipe is like the amount of voltage in an electrical system. If you have more pressure, it is like having more voltage. If you restrict the flow of water in the hosepipe by turning a valve or by standing on the hosepipe to restrict the flow of water, it is like increasing resistance in an electrical circuit. By increasing the restrictions to the water, you are increasing electrical resistance or electrical flow. The amount of power out the hosepipe by the jet of water is like electrical property of power measured in watts. The amount of power done over time is called energy and is measured in watt hours. The electrical terms: volts, the symbol V or E or EMF is in a battery is like water pressure in a tank. A potential amount of electromotive force is measured in volts. Amps with the symbol I represent electricity flows through a wire in much the same way that current flows down a river, measured in amps. Resistance with the symbol omega or ohms is resistance to flow through a wire is much the same way that rocks, etc. flow down a river, measured in ohms. Power measured in watts is equal to voltage, volts, times your amperage or amps. Watt is a unit of work done over time. More watts, then more work is getting done quickly. Less watts means less work. 1000 watts of power, for example, equals 5 solar panels with an output of 200 watts each. And if they each run for 1 hour, that is equal to 1000 watts hours or 1 kilowatt hour. Alternatively, think of it as 10 light bulbs, each of 100 watts burning for 1 hour, which equals 1000 watts hour or 1 kilowatt hour. Electrical potential difference or EMF, electrical motive force, is voltage. Batteries, wall plugs, solar panels in the sun have a voltage. Heat decreases PV voltage. That means as temperature decreases, PV voltage increases. The symbol for voltage is V or E or EMF. Amperes is current. The symbol is I for intensity. Amperage is the killer. It stops your heart, paralyzes muscles in very small amounts. PV, photovoltaic amperage, increases proportionally with increased sunlight. The relationship between voltage, amperage and resistance is in this simple mathematical equation called Ohm's law of voltage, which equals amperage times resistance, and can be manipulated to be amperage equals voltage divided by resistance, and resistance to equal voltage divided by amperage. A second part of Ohm's law is Ohm's power law, which is a simple mathematical equation that says power equals amperage times voltage, and can be manipulated to solve for either voltage or amperage. Power is measured in watts. 1 amp times 1 volt equals 1 watt. Energy is measured in watt hours or kilowatt hours, and the utility sells energy, which is measured in kilowatt hours. The graphical representation of electrical is standardized, and the study of the symbols makes it easy to read basic electrical diagrams. In many solar systems, a one-line diagram is more common to see, as seen in the bottom of this slide. Digital multimeters are essential tools to understand how systems work. There are two basic kinds. One on the left is a digital meter with testing leads, and the one on the right is a digital meter which also has testing leads, but is called a clamp-on digital meter. Digital multimeter warnings. Do not rotate the dial while the meter is connected to a circuit. You may rotate it through a current range, short-circuiting the probes and damaging either the meter or the circuit. Respect the circuitry you're working on. If you touch exposed metal or cause a short circuit or connect high voltage, you may expose yourself to hazards or damage the circuit on your meter. Measuring the short circuit current of a battery or power supply is usually not safe. It is likely to damage the meter or battery and possibly cause the battery to overheat so much that it may be dangerous. Measuring voltage. To measure potential difference or voltage, the circuit is not changed. The voltmeter is connected in parallel at two different points and the voltage is measured. To measure current, the circuit must be broken to allow the ammeter to be connected in series. To measure resistance, the component must be removed from the circuit altogether. Ohmmeters work by passing a current through the component being tested. There are two ways to connect the components of an electrical circuit. The two most common and easiest ways are called series and parallel. In a series circuit, modules or components are connected along a single path, allowing the same current to flow through the circuit at any given point. In a parallel circuit, modules are connected on dual paths so that the voltage is equal throughout the circuit at any given point. Series and parallel arrays. Here we see 4 solar panels connected in series and another 4 connected in series below. These two arrays, 1 and 2, are connected in parallel. In series circuits, voltages add as shown on the top 4 modules, adding up to 120 volts. 30 volts plus 30 volts plus 30 volts plus 30 volts equals 120 volts. And the same in the lower 4 modules, adding up to 120 volts. Note that the current, measured in amps, 0.5 per module, remains the same in a series circuit. When the two arrays of 4 modules are connected in parallel, as shown on the left, the voltage remains the same, but the currents are added to 1.0 amps in parallel, and the voltage remains at 120 volts. Solar modules are a photovoltaic system's building blocks. While each module or battery has a rated voltage, amperage and wattage, they can also be wired together to attain a desired system voltage and current. Series circuit connections are made at the positive end of one module to the negative end of another module. When modules are connected in series, the voltage increases. Series wiring does not increase the amperage produced. Series circuits can also be illustrated with batteries. Batteries are often connected in series to increase the voltage and power a higher voltage device than one single battery could provide. For example, when 3 batteries of 12 volts each are connected in series, the total voltage available is 36 volts. The voltage measured from this terminal to this terminal is 12 volts, but when measured from this terminal to the second battery terminal, it's 24 volts. And when measured from this terminal to the third battery, measures 36 volts, shown below. However, the amperage measured in the circuit is always 40 amps. Parallel wiring connections are made from the positive plus to the positive plus terminals and negative minus terminals to negative minus terminals between modules. When modules are wired in parallel, the current increases. Parallel wiring does not increase the voltage produced. Parallel circuits can also be illustrated with batteries. Batteries are often connected in parallel to increase the current for devices requiring higher amperage than one battery alone could provide. For example, when 4 12-volt batteries are connected in parallel, they produce 6 amps output each, but the amperage increases and the voltage remains the same. So when you measure the amperage across one battery, it is 40 amps. Measure the amperage across 2 batteries, it's 80 amps. Across 3 batteries, it's 120 amps. And when measured across the 4 batteries, it's 160 amps. But regardless of where you measure the voltage in the system, it always shows as 12 volts. Here, 6 modules are connected in series, minus plus, minus plus, minus plus, indicating a series circuit. When you measure voltage across each module, the voltage adds and the amperage remains the same. 44.8 volts plus another 44.8 volts is 89.6, plus another 44.8 is 134, and so on, till the total voltage measured across the system is 268 volts. And although each battery is 5.4 amps, regardless of where you measure the amperage, it is always 5.4 amps. In the same way, the wattage increases. 185 watts measured here, here it is 370, plus another 185 is 355, and measured across the entire circuit it is 1110 watts. Similarly, 6 modules connected in parallel, pluses to pluses, minuses to minuses. Each module the current is additive and the voltage remains the same. 48.4 volts measured here, 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 and here always measures 48.4 volts, but the current is additive. 5.4, 10.8, 16.2, and finally, if you measure it across the entire system, is 32.4 amps. However, the amperage likewise increases. Remember, power is voltage times amperage, and for the system it is 44.8 volts times 32.4 amps equals 1110 watts. It's important to know what materials conduct electricity and what materials are poor conductors or insulators of electricity. Note that pure water is not a conductor, but dirty water is a conductor. The best conductor of all is gold. Used in electrical system, it is aluminum and copper. Now, watch the video, the second video in this section of the course. When that is complete, take the exercises in this section of this course. And thanks for watching. And if you have any comments or problems, please leave a message for me, the administrator. Thank you.